So before we start, I just wanted to go over a few assumptions we made when coming up with this presentation. First, you have a basic knowledge of Python. You've worked with geoprocessing. You've maybe written some Python scripts or can at least understand when looking at Python code. You have a basic knowledge of Enterprise Geodatabases and Enterprise Geodatabase workflows. This session, we're really going to go through a number of workflows. We're going to talk about how to do the things, not necessarily why you want to be doing those. So we're assuming you have that background knowledge already. Finally, that you're going to want the code, you're going to want the slides. Don't worry, at the end of the session, I'll have a link to both the slides as well as all of the code that I'll be demoing today. So that should be easy for you to find. Also, if you haven't already, please remember to turn off or silence your cell phones. This session is divided into 3 parts. The first part, we're going to be talking about the geodatabase and looking at the geodatabase from the administrative perspective. The second section, we're going to talk about geodatabase creation. So here we're going to be talking about creating geodatabases, creating roles, creating users, applying permissions, creating schema, all those things. In the third section, we're going to talk about version maintenance. So this is where we're going to focus on the reconcile process. We're going to talk a little bit about user management in this section as well. We're going to have a lot of demos throughout the entire session. We're going to start off pretty slow and pretty basic and work our way into more complex scripts. So why Python? I don't really need to go through all the bullets on this slide. The main thing I want to draw your attention to is that this, working with Python is cross-platform. So if your geodatabase is on Windows or Linux, you can use Python and all of the stuff you'll see today on either platform. So what is the geodatabase? Well, for most of you, you probably think about it as the store where you're putting your data. You have tables, you have feature classes in your geodatabase. It's also part of the ArcGIS information model. So if you want to model real world things, we have things like various types of networks. We have domains and subtypes that are part of the information model that allow you to effectively model your data. It's also a transactional model for managing GIS workflows. So things like versioning, replication, even editing, a lot of that infrastructure is controlled through the geodatabase, through the transaction model of the geodatabase. If you're writing applications, you can also think of it as a set of components for accessing your geodata. And so when we talk about the geodatabase, we're really talking about sort of 2 distinct sets of tables. The first set are the system tables, also commonly referred to as a repository table. I'll be using those 2 terms probably interchangeably throughout this session. The first set of tables, these system tables, are what track contents of your geodatabase that stores instance level metadata. So things that aren't specific to a particular data set. So versions. A version spans the entire workspace. It's not specific to a particular data set. Same with domains. You can apply domains to individual data sets, but they live in the geodatabase at the workspace level. So the type of administrative options you're going to be performing on these system tables are things like version management, content management, geodatabase upgrade, the things I've listed here. The second set of tables that we're going to talk about are the user data tables. So these are the tables that most people are very familiar with. These are your feature classes, your various data sets. These are the things that you actually see when you pop open a geodatabase and browse through it. So the type of administrative options that we're going to perform on the user-defined tables are things like granting and revoking privileges, changing the structure of the tables themselves, things like adding and deleting fields, renaming fields, granting or revoking privileges, enabling archiving, enabling versioning. Those are the things that happen actually on the individual data set level. And so to do all of this administration, we have different types of administrators. We have the database administrator, the DBA. We have the geodatabase administrator. We have the data owner. You can think of this as the data set administrator. And depending on your organization, this might be 1 person, this might be 3 people, this might be more than 3 people. Generally, larger organizations will have an individual person managing each one of these types of administration. In smaller organizations, typically you have one person doing all three types of administration. So first up, we have the database administrator. This commonly referred to as the DBA. So this is the user that's responsible for, typically they're going to install the instance, they're going to perform user management, database backup, they're going to be looking at performance monitoring and security on the database instance itself. The next up, we have the Geodatabase administrator. So this is the user that owns all of those system repository tables that I spoke about earlier. And because they own these repository tables, they have special privileges within the Geodatabase. So they can view and reconcile any version in the Geodatabase. They're typically the user that performs the compress. They do log file and configuration keyword maintenance. Also, any data that's been registered as versioned, the Geodatabase administrator has full editing privileges on that data. The final administrator we have is the dataset administrator or data owner. And again, this is the user that's going to be responsible for managing the individual data tables. So some of the things I mentioned earlier, like registering as versioned, enabling or disabling archiving, the things that are actually happening on those user data tables. So when working with Python, the way that you connect as any of these users is through a database, an SDE connection file. This controls who and how you're connected to the geodatabase as. So the who, that determines the type of permissions that you have in the geodatabase, whether you're connected as the database admin or the DBA. You provide that information into the connection file. It also determines how you're connected to the geodatabase. So determining actually what database you're connected to or what version within the geodatabase you're connected to. Working with Python, you're always going to use a database connection file to connect to your geodatabase. That's a little bit different than some of the other ArcGIS APIs. So how do we create a connection? We do that using the create database connection geoprocessing tool. This creates an output SDE file. You're probably familiar with these SDE connection files. They're the same thing that you would create by going into your add database connection in Arc Catalog or via your project pane in Pro. So let's move over to our first demo. Okay, so in this demo, I'm going to show you how to create the database connection file. This is the create database connection tool. I'll just pop it open so we can see some of the parameters here. We can see it takes a location and a name, and then a bunch of information about how we want to connect to the geodatabase. Also down at the bottom, we can see some optional geodatabase connection properties. So let's see what it looks like through Python. So I've typed in arcpy create database connection. We can see here on the right-hand side that as I'm typing in the IntelliSense, or the prompt on the right-hand side will let me know what parameter I'm on, the name of the parameter. As I type in certain parameters, when we can, we will use IntelliSense to give you options. So the first thing I need to do is provide an output folder path. So I'll just drag and drop that into the window. The next thing I want to do is provide a name. So I'll provide a name for the connection file. All my demos today are going to be on SQL Server, so I'll just choose SQL Server. The instance, I need to provide the instance name that I'm connected to, that I want to connect to. And then I can choose whether I want to use database authentication or operating system authentication to connect to my geodatabase. In this case, I'm just going to use operating system authentication. And then because I'm using operating system authentication, I can just stop entering parameters, and it's going to make the basic connection to my geodatabase. So we can see that connection file's been created. Have any of you worked with the arcpy describe function? Most of you probably that have written scripts. So I wanted to show that. The The workspace properties are available from arcpy describe when you describe a connection file. So this is how you can get information about the connection properties of your connection file. So here we can see there's an object that's returned from describe called connection properties. And on the connection properties, we have all of the various properties that we would expect to see in the connection file. We can also get other information about the workspace, such as the domains, the release of the geodatabase, and the workspace type. So I'll just show quickly a few of the what this looks like when we run it from Python. So here we can see I'm calling arcpy describe. I'm passing in a connection file, and then I'm asking for the connection properties, and from that I'm asking for the database. I can do the same thing if I want to connect to if I want to see the version that I'm connected to. So I'll do that, and we can see that I'm connected to SD default. And you'll note that when I created my connection file, I didn't actually provide default in the parameters for creating the tool. This is what we will connect to whenever the version is not provided in the tool. We'll default to the default version. Okay, so that's the first demo, pretty straightforward. So that concludes the first section. The next section we're going to talk about is geodatabase creation. So there's two ways using Python that you can create enterprise geodatabases. The first is to enable geodatabase behavior in an existing database. So you would do this in the case where you already have a database. Maybe you've already loaded data into the database. You have users in that database. Permissions have been applied on the various tables, but you want to maybe take advantage of some geodatabase functionality. Maybe you want to take advantage of domains or subtypes or any of our various data set types. So in order to do that, you can enable geodatabase behavior in an existing geodatabase. The way you do that is through the Enable Enterprise Geodatabase GP tool. So the other way of creating an enterprise geodatabase is using the Create Enterprise Geodatabase GP tool. So this is the tool that you would use if you're basically starting from scratch. You don't have an existing database, you want to create one. Maybe you're setting up test environments, maybe you're automating your geodatabase creation for some reason. This is the tool that you would use for that. One thing I forgot to mention on the previous slide, you would run that as the Geodatabase administrator when you're running the enable, and for create you would run that as the DBA. And the reason you need to run that as your DBA is because there's extra permissions that are required, such as actually being able to create the database and create the Geodatabase administrative user with some elevated permissions. Okay, so once you have your geodatabase created, you're probably going to want to have people access it. And in order to do that, you can create users in your geodatabase. You can do that using the Create Database User tool. So this creates the user in your enterprise geodatabase or database, and it creates users with privileges to create data in the database itself. One thing the tool cannot do is create the geodatabase administrative user. So you cannot use this tool, for example, to create the geodatabase admin that you would then use in the enable geoprocessing tool. The geodatabase administrative user requires a little higher level privileges. Again, this is something that you would do as your DBA. Okay, so going right along with creating users, you can also create database roles, and this makes it really easy for you to manage privileges in your geodatabase rather than assigning privileges on individual data sets to individual users. You can group users into these roles and then assign privileges to a number of users at once by only assigning privileges to the one role. In order to do this, we have a Create Role GP tool. And again, this is something that is run by the DBA. So we'll move back over to another demo. Just clean up a little bit here. So I wanted to show the Enable Enterprise Geodatabase tool. It's pretty straightforward. It's probably not really worth demoing. It takes an input database connection as the Geodatabase admin user, and then a authorization file, and then this will lay down those system tables in an existing database. What I would like to demo is the Create Enterprise Geodatabase tool. Oops. Create Enterprise Geodatabase. So again, I'm working with SQL Server, so I'll provide that information. I'll provide the instance name. I'll provide the database name that I want to create. And then what I need to do is, this is actually going to create a database in my SQL Server instance. So I need to provide the DBA credentials in order to have those permissions to create the database and create the Geodatabase admin user. In this case, I'm going to use operating system authentication to connect to the instance. So because I'm using operating system authentication, I don't need to provide a username or password. I then have an option. This is an option that's specific to SQL Server. I can choose who I want to own those system repository tables, and this will be the user that becomes the Geodatabase administrator. In this case, I'm going to choose SDE schema. So my SDE user is going to be the user that is my Geodatabase administrator. So then I need to provide the name and password. And then table space name, this is something that's specific to Postgres and Oracle, so I don't need to provide that because I'm on SQL Server. And then my authorization file. So now I'm ready to run. The tool is going to connect to the Geodatabase. It's going to do some checks on my privileges. And then it's just going to install all of this. It's going to create the database, create the Geodatabase administrative user, and then create all of those tables in my Geodatabase. Okay, so now that's done. I've created my Enterprise Geodatabase. To save time, I've already created a connection to the Geodatabase. And now what I want to do is I want to start creating some roles and users in my Geodatabase. So the first thing I'm going to do is I'm going to use the Create Role GP tool to create a role in my database. So create role, it's going to take a database connection from my DBA, and then I'm going to provide the role name. In this case, I'm going to create a role called editors. I'm going to run that, and now my role has been created in my Geodatabase. With the role created, I want to start creating some users, and I'm going to use a list here to create a bunch of users quickly. So I'm going to create a user list. And I'm going to add 3 users to that list. So I've created my users, and now I'm going to just iterate through this list and create individual users based on each item in this list. And I'm going to create the users using the Create Database User GP tool. So create database user. Again, I'm going to pass in my DBA credentials using the connection file. I have an option to create both database or operating system authenticated users. In this case, I'm just going to create database authenticated users. And then I need to provide the username. So for this, I'm just going to provide the user from that list. And I'm going to use the password. I'm going to set the password as the same as their username. And then what I want to do here is I want to add each of these users to the editor role that I just created. Editor's role that I just created. So I'll go ahead and run that. And we can see on the right, we got some status indicating that the database users have been created. If we go into Management Studio, I can refresh and we'll see that my Demo 2 Geodatabase has been created. I can browse into that and see the various users in the Geodatabase. We can see Colin, Matt, and Tom have all been created. And if we go into the roles, we can look and we can see the editor's role. And within the editor's role, we can see that Colin, Matt, and Tom are all members of that role. So when I want to start delegating privileges, I have these roles now that I can use. All right. That's it for demo 2. Okay, so that was a pretty straightforward demo on how to create an enterprise geodatabase. Once you have your geodatabase created, you're probably going to want to start loading data or creating data in your enterprise geodatabase. We have many tools for creating and loading data into your geodatabase. Most of the creation tools start with the word create. Creating tables, creating feature classes, all of the very basic types of data sets. We also have tools for creating some of the more advanced data sets, creating geometric networks, topology, domains, that sort of thing. So we also have tools for loading data. So you can take existing shape files, file geodatabases, all the various data sets that we support, and you can load those into your geodatabase as well. We have tools for importing and exporting XML workspaces. So for example, if you had a file geodatabase that had a schema in it that you really like, you can export that schema or export that data and then import it into your existing geodatabase via an XML format. Of course, if you're really savvy with Python, you could write a custom script. So if there's a data set type that ArcGIS doesn't support that you can access via Python, you could always write a custom script to read that information in Python and translate it into a format via Python that ArcGIS understands. And of course, when you're loading data, you're always going to be loading it and creating it as the data owner. For those of you that really like to manage how your geodatabase stores data in the underlying database, we also have tools for managing your configuration keywords. We have 2 tools, one for exporting and one for importing. I have them listed here. The workflow is to export your existing keywords. It exports to a text file. You edit that text file to contain the new keywords that you want or tweak existing keywords, and then you import that into back into your geodatabase and essentially overwrites your existing keywords. And this is something that you need to do as the geodatabase administrator. So once the data is loaded into your geodatabase, you're going to want to manage privileges to determine who can access that data. To do this in Python, you use the change privileges GP tool. This allows multiple data sets to be passed into the tool, and it allows you to grant either view or edit privileges. So view privileges would equate to select. Edit privileges would equate to select, insert, update, and delete. Again, this is something that you would do as the data owner. Okay, another demo. Getting into some more exciting demos now. How's the text size in the back? Is it okay? Little bigger? Good? All right, cool. Did I hear a meow? Okay, so in this demo, we're going to, I have it listed here. We're going to create an enterprise geodatabase. We're going to load create some schema in that geodatabase. We're going to create users and roles in that geodatabase. We're going to create versions, and we're going to apply permissions to the schema that we've created. To do this, we're just using the arcpy module. I've saved a little time by starting the debugger to get us to our first breakpoint. So first here, I'm just setting a bunch of parameters. Most of these are just parameters for connecting to the geodatabase or for creating the geodatabase. So the first thing we're going to do, we're going to run the create enterprise geodatabase tool, passing in a bunch of those variables that I set earlier. We'll take a minute, and then once we have our connection, or once we have our geodatabase created, we're going to create a connection as the DBA user. So we've created an admin connection. We're holding that in this admin variable here. And then we're just going to run the create role tool to create both a viewer role as well as an editor role. So then I have two sets of users that I want to create. I have a set of editors and a set of viewers. So I've created two lists. And very much similar to my previous demo, I'm just going to iterate through these lists. And for all of the editors, I'm going to add them to the editors role. And for all of the viewers, I'm going to add them to the viewers role. So now I've created my roles and I've created my users. The last thing I want to do is create a data owner user. So in this case, my data owner is going to be named GDB, and I'm just going to create that user separately, not adding this user to any given role. So now I've created my data owner user. I want to do some configuration keyword management, so I need to create a connection as my geodatabase admin. So again, I'm going to create a new connection file. With that new connection file I've created, I can run the import geodatabase configuration keywords tool to import an existing keyword that I've already updated and is ready to be loaded into my geodatabase. So now that I've created my keyword, I created a keyword actually. One thing to note is the keyword that I created is named custom. So now I want to do some work as the data owner. Again, I'm going to create a new connection using create database connection. And then I'm going to import an XML workspace document that contains a bunch of schema for my geodatabase. Okay, so the data has been, the schema has been created in my Enterprise Geodatabase. I'm now setting my workspace to point to my data owner connection, and then I'm going to run some of our arcpy listing functions to get lists of tables, feature classes, and feature data sets in the geodatabase. This list that I'm using, I'm going to use to both register my data as version and apply privileges. So now I have my list of data. I can change privileges on the data list by using the change privileges tool. So here for the viewers role, I'm granting view privileges. And for the editors role, I'm granting both view and edit privileges. Now I'm going to go through and register all of the data in my list as versioned. So we can, to do this, we're just running the register as version tool, and we're just looping through every data set in the data list and registering it as versioned. So finally, the last thing I wanted to do was to create a version for each of my editors so that they can connect to the database, connect to that version, and just get started editing. So to do that, I'm again going to loop through my editor list. I'm going to create a database connection for each user. And as I'm going through this loop, I'm just going to overwrite the existing connection. I'm going to create a version using the create version tool. The name of the version is going to be the username _ edit version. And these versions are going to be set to private, so only that user can see that version. That user in the geodatabase admin can see that version. So I'll run through this. This usually takes a minute or two. Okay, so we're done. We've created the versions in the Geodatabase. So if we go back, we can take a look and see these are some of the connection files that I created during the script. I could have in the script just deleted these, but for demo purposes, I left them here. You could of course just delete the files from disk as your script processes. So if I connect as the data owner, I can look at the various data sets in the Geodatabase. So these were the data sets that were created by importing that XML workspace document. If I right click on one of these feature classes, I can go to manage and I can take a look at the privileges. And we can see here, as expected, my editor's role has been granted full editing privileges on the data. My viewer's role has been granted select only privileges. Of course, the SDE user, which is my Geodatabase administrative user, has full editing privileges, again, because the Geodatabase admin is granted editing privileges when your data is registered as versioned. If I connect now as my Geodatabase admin user and go and take a look at the versions in the Geodatabase, we can see that the 4 editors each have versions created for them. They are the owners of the versions, and we can see over here on the right that each of these versions is a private version. Okay. Okay, so in that demo, we saw how to create a geodatabase, create users, create schema, roles, apply privileges to the data. And then this is our last section, moving on to version administration. So the parts of the version administration workflow that we're going to focus on is the reconcile process. We're going to talk about reconciling, posting, compressing, updating statistics and indexes, as well as managing user connections. So first up, we want to talk about why we might want to disconnect users. You may have some users that are connected to your system. They've gone home for the day. Maybe they have some locks on the data and you want to make some changes to that data. Maybe your DBA needs to perform some maintenance on the server and you need to disconnect users. Maybe you have large queries that are going to take up a lot of resources and you really want to get everybody off of the system. And finally, maybe sometimes you might want to disconnect during the reconcile process. So for managing user connections, we have a number of functions. The first function I'm going to talk about is the accept connections function. This is a function you provide the admin connection as well as a Boolean value indicating whether connections are going to be accepted to the geodatabase. If you provide true, it means connections are allowed to the geodatabase. If you provide false, any new connections coming into the geodatabase will be refused. Note that it doesn't actually disconnect existing connections, so it allows users that are doing their work to, if you do block connections, they can continue doing their work, disconnect gracefully, but then the next time they try to connect, they won't be able to. For finding who's connected to your geodatabase, we have the list users function. This returns information about who's connected and how they're connected to the geodatabase. And finally, we have the disconnect user function. This is actually the function that will allow you to disconnect individual users or all users from your geodatabase. To use this, you again provide your admin connection, and you either provide the ID, the session ID for the user that's connected that you would get from the list users function, or there's an all keyword that will just disconnect all but your existing connection. So are many of you working with services published from your Enterprise Geodatabase? Okay, I see more and more hands every year. It's good. So one thing to note when you are working at the geodatabase level and you're going to be disconnecting users from your server, from your geodatabase, it doesn't really see the server as anything different than a regular user. There's nothing special about the ArcGIS server connection when you're down at the geodatabase level. So if you disconnect all users from your geodatabase, that will include any users that are connected to your geodatabase serving up services. ArcGIS server has logic in it that will try to reattempt to connect. So if you do not block new connections, you then disconnect all users, eventually ArcGIS server is going to start trying to connect again. So really, if you're going to be working with services and you do need to disconnect all users for whatever reason, you want to block connections because ArcGIS server will continue to try to connect, and then may get locks on your data or whatever you're trying to avoid server doing. So the workflow we'd recommend, you block connections, you can stop your service, perform your administrative tasks, allow connections again, and then start your service. Back over to a demo for connection management. So I'm going to start off by, actually I'll clear this out. I'm going to start off by creating a few connections to the geodatabase. So I've created these 3 connections. Let's block connections to the geodatabase. Oops. ArcPy accept connections, and I'm going to provide my admin user, and I'm going to say false. So this indicates that connections are no longer allowed to the geodatabase. So I have some other connection files here that are going to try to connect to the same geodatabase. When I try to use these connection files, we get an error message, and we can see the error message is saying that the geodatabase is not accepting connections and you need to talk to your geodatabase admin. Okay, so now let's find out who's connected to this geodatabase. So I'm going to use the list users function. Again, passing in my admin connection. So I'll print this. And we can see a whole bunch of information here. It's kind of hard to read, so let's clean that up a little bit. We can see from this information it has the connection time, client name, the name of the user, the type of connection, and the connection ID. What we're really interested in here is the username and the connection ID. I forget whether it's uppercase. We'll find out soon enough. I got it right. Okay, so now we can see here we have 5 connections. So this last connection is the connection that I'm using to actually find out who's connected. We have this feature server user, and this is actually a user coming from a feature service that has been published from the data in this geodatabase. And then we have this Brent, Colin, and Craig, these 3 connections that I just made during this demo. So if we wanted to be mean, we could just disconnect everybody using the all keyword, but let's get a little bit more fancy and just disconnect the Brent, Colin, and Craig users. So in order to do that, I'm going to use a list comprehension to just get the IDs of the users who are not SDE and feature server. No. If. Need to recall my notes. These list comprehensions can be tricky. If user name. There we go. Probably should have copied and pasted that in there. So what we're doing here, we're getting the user ID for each user in the user list if the user name is not feature server or SDE. So now we can see I just have those 3 users, and now I can disconnect those users. Pass in my administrative connection and my list to disconnect. And now if I regenerate my, my list of connected users, we can see just the feature server and SD users are connected. So now we're still blocking existing connections to the geodatabase. So again, if I try to connect, it's not going to work. So I'll allow connections again to the geodatabase. And we'll see that these other users can now connect. So now if I try to connect as Gary, Heather, Matt, they can all connect to my geodatabase. All right. Okay. So moving on to reconciling and posting versions. So you're going to want to reconcile and post when you want to push and pull changes between different versions in your geodatabase. To do this in Python, we use the reconcile versions tool. We recommend that you run this tool as the geodatabase administrator. The reason for this really, you could run this as any user, but running it as the geodatabase administrator gives you access to all of the versions in the geodatabase, so you don't have to have any logic in your script that, that tries to figure out whether you're the owner or various properties of the versions. You have access to all the versions, you can reconcile all the versions, and you're good to go. After you reconcile your versions, we always recommend that you compress your geodatabase. This is going to remove extraneous data from your geodatabase and help it perform better. Again, this is something that you run as the geodatabase admin. And we've always recommended that you update statistics and indexes after your reconcile operations. But this holds true for really any major data change event. So if you're having major changes to your data, you should keep your statistics and indexes up to date as well. The statistics and index management can and should be done by both your geodatabase admin on the system tables, and then as the data owner on any data that they own that would be affected by the reconcile. Okay, one more demo. Okay. Okay. So this demo, I really like this demo. What we're going to do here is we're going to perform reconcile-post-compress. We're going to update statistics and indexes after the compress, both on the system tables as well as on data tables owned by the users. The other thing that we're going to do in this script is we're actually going to keep track of the success and failure of each operation that we're performing. And then we're going to use that information to send ourselves an email, kind of a log file of what happened, so that we can review that at a later time. So in order to do this, we're using arcpy. I'm using this SMTP lib for sending emails. There's a bunch of Python libraries, so this case this demo is specific to this library, but like you can get libraries for working with Gmail or various other ways, other protocols. Okay, so the first thing I'm going to do here, I'm going to get a connection as my geodatabase admin user. I'm going to set a couple of my workspace variables. I'm going to block connections to my geodatabase using the accept connections. Yes, I can. Say when. Okay, that's good. All right. I could go really big. That's probably too much. Okay, so accept connections. I'm passing in my admin connection and blocking connections to my geodatabase. Now here, I'm not using any fancy logic. I'm just using the disconnect user function to disconnect all users from my geodatabase. So this is going to disconnect all but the connection that's actually used to disconnect. Next up, I'm going to get a list of all of the versions in my geodatabase. Because I'm connected as my geodatabase administrative user, I have access to all the versions in my geodatabase. And what I'm doing to get that list of versions, I'm using this DA, this arcpy DA list versions function. There's actually, within arcpy, there's two functions for listing versions. There's one that's just arcpy list versions. That returns a list of version names and just the name. The arcpy DA list versions returns version objects. So those objects that you get back, you can actually ask questions of. So I'm using the DA option that returns those objects. And then again, it allows me to use this list comprehension. What I want to do in this case is only get versions that are children of default. I don't want grandchild versions of default. I only want to reconcile the versions that are children of default. So to do that, again, I'm using a list comprehension. I'm just getting the version name for each version in the list if the parent version name is default. So now that I have my version list, I'm ready to start reconciling versions. I pass in my Geodatabase admin connection and my version list. And the other option here I want to draw your attention to is this last parameter here is for a log file. So the reconcile versions tool will actually write out a log file for you indicating which version is being reconciled with which version. If you choose to post, that it will give you a message indicating that it's posting the version. And so I'm actually going to write this log out, and down here, my next breakpoint, what I'm doing in this bottom section is I'm actually keeping track of, I'm making basically a string variable here that I'm holding on to messages that I'm creating as I execute each of these various tasks. So my reconcile message here is that the reconcile and post executed successfully. The reconcile log is below, and then what I'm doing is I'm just actually reading that reconcile log that I just created into this string variable. And then I'm going to use this again later on when I send myself an email. And I follow that pattern for each of the various tools that I run. So I actually run the compress, and then I set a compress message. The next thing I want to do is I want to rebuild indexes on the system table. So I'm still connected as the Geodatabase admin user, and I want to update the statistics and indexes on those system tables because I've just performed a reconcile, post, and compress. So I run the rebuild indexes tool. I pass in my Geodatabase admin connection, and I provide the parameter system. There's two parameters here that I can provide. I can provide either system or no system. When you're connected as the Geodatabase admin, you're allowed to use the system parameter. If you're not connected as the Geodatabase admin, this parameter, and you try to use the system parameter, it will fail. You need to provide no system if you're not connected as the admin. Again, if it's successful, I add a new message. I do the same thing for my statistics, and to do that, I run the Analyze Datasets tool, again passing in the system parameter. So now I've finished my tasks as the admin. I want to allow connections to the geodatabase so that my data owner can connect and do the maintenance that my data owner needs to perform. So I'm going to use accept connections, passing in my admin connection, and setting true to allow connections to the geodatabase. So now I have a owner connection that's been provided to me. I don't necessarily know who the data owner is, so I'm going to use the arcpy describe function to figure out this information. So I have that connection, I describe, I get the connection properties using the connection properties object, and then I get the username from that. And now I use the username as a wildcard in the various listing functions. So I want to get a list of all of the data that's owned by this user. I'm on SQL Server, so I know that the naming convention for tables and feature classes is database.username.tablename. So I'm just adding a star.username.star to find any data that's owned by this user. I'm doing that for the tables and feature classes. I'm then going through each of the feature data sets and listing all the feature classes in the data set. So that will return me a list of all of the data that's owned by the user coming from the connection file that was provided to me. So now what I want to do, again, I'm going to run the rebuild indexes and analyze datasets tool. This time you'll see I'm not passing in system, I'm passing in no system. And I'm passing in the data list that I just created. Okay, so that's that's all of the geoprocessing stuff that I needed to do. I've reconciled, post-compressed. I've updated my statistics and indexes. So now I'm just setting this parameter to true, indicating that if I've made it this far, things are looking pretty good. So then I check that variable. If it's true, I set the subject line for the email that I want to send. So this is just a summary. We can see that if the script success was false, we would have had a different message for our email that would be sent to us. Then for the message body of my email, I'm just pushing together all of the various messages that I've been keeping track of. So my reconcile message, compress, and then my system, my indexes and statistics on both my system and data tables. That's going to be the message body of my email. So I have a function that I've written called send email. It takes a subject and a message. I connect to my server, providing some information about how I want to connect. I connect to the server and send the email. So now my script's done. I should get a pop-up in my mailbox. This has been known to take a minute or two, especially when you're demoing. Should I wait? Yeah, there it is. Come on, Toaster. Oh well, okay. Toaster didn't pop up, but we can see the, there it is, of course. So we see we got the email in my inbox. I can open it up and I can see the reconcile completed. We can see the information from the reconcile log. We can see that compress was successful, and then all of the other various operations that I performed were successful. If any of these had failed, I had a different message that would have been returned and returned in this email. So this is a pretty cool script. It automates your geodatabase maintenance, your version maintenance. But we can take it a step further. You know, I was sitting here in front of my machine. It's really nice if you want to sit here in front of your machine every day and run this script. But really, probably you want to be running this regularly, and you don't want to be there when it's running. So in order to automate it, you can use a task scheduler. So in this case, I'm on Windows, so I'm working with the Windows task scheduler. And what I'll do, I'll create a basic task. I'll call it run reconcile. Oops. Run reconcile. I'll choose to do it weekly, and Monday, Wednesday, Friday. What I want to do is start a program. That program is simply just the Python executable that's installed with ArcGIS. And then the argument that I want to add is this is just the path to my Python file. So this is the script that I just demoed. I'm setting it to Python exe to open and run that Python script. The last thing I want to do, I want to check this box to open some properties. And by default, it's only going to run if I'm logged in, but I want this to run whether I'm logged in or not, and run with the highest privileges. So I'll click OK, and then it's going to prompt me for my username or for my password so that it can run that when I'm not actually logged into the machine. Okay, so now this script is going to run 3 times a week. You could set this to run in off hours or whenever's a convenient time. On convenient days, you could have it run every day. You could have it run multiple times a day, however you want it to run. All right. So that's it for the last demo, and we're almost done here. Yeah, so in summary, just want to say the Geodatabase is open to Python developers. If you're looking to administer your Geodatabase, we have a lot of options there. There were a number of tools that I wasn't able to cover in this session today. Take a look in the data management toolbox. There's a Geodatabase administration tool set in there that has a number of tools that I wasn't able to cover. Please, if you have a moment, I'd really appreciate it if you could fill out your survey. The feedback that we get is really valuable to us. It really lets us improve our sessions year to year. So if there were things that you were hoping to see in the session that you didn't, please let me know. If there was anything you'd like, maybe a deeper dive or anything like that, of course, we're always open to feedback. As promised, the slides and code can be found here. So this is a QR code that will take you directly to the slides and the code on GeoNet, and then this is just a short URL that you can also type in. So with that, I'd like to open the floor to any questions in the back.
So quick question. So when you implement the block connections, that was an approach we took for a little bit, but what do you recommend in terms of best practices for exception handling and allowing users to reconnect in the event that your script fails? You know, we all should be using proper exception handling, but if you are superstitious and want a foolproof way, what do you recommend?
So the question was, if I can summarize, was how do you recommend handling the blocking connections if your script fails? I really think, yeah, it's probably some sort of exception handling. There's not really I don't really have a great answer for if your script fails, how do you allow connections back to the geodatabase? Again, maybe setting it up as part of an email, like I demonstrated today. You could, if the script fails, you could email yourself, catch that and send yourself an email indicating, hey, something happened with the script. We weren't able to turn on, to allow connections again.
When creating roles, can you use active directory groups to assign to that role as opposed to user and
The question was, when creating roles, can you use Active Directory to assign Active Directory groups? I'm not sure. I believe you can, but if you want to see me after, I could give you a card and get the correct answer for you. I believe you can. The gentleman in the front says you can, but it's messy.
So I've modified an old version of your script and I've been running it. And sometimes so it runs at night, it's a scheduled task. But I can't get down to the zero state. And so I come in the morning, I look, it's not at the zero state in compression. But if I look at the log, it looks like everything compressed, well, not compressed, synchronized, everything synchronized successfully. And then for whatever reason, I have to go in and do another compress manually.
So the question was,
I guess my question is, have you heard of any other issues that we're having?
Yes, so the question is, I'm running a compress, but I'm not getting rid of every single state in my geodatabase. That's a common question. It's a successful reconcile, a successful compress doesn't necessarily mean that you're always going to get down to state 0 in your states table. There could be, I believe there might be a parameter in the reconcile tool that will allow you to avoid taking locks. That might be the option for you. But I would say, even if you don't get to state 0, I wouldn't put too much concern on that. Just the next time your script runs, you should be able to get rid of those states that weren't compressed the first time. Getting down to state 0 shouldn't be the goal of every single compress.
So if it's not at state 0, will the child still see all the changes that are from the parent?
Yes, yeah. So the question was, if you're not at state 0, will the child see all of the changes that's in the parent? Yes, the child will always see the changes when you perform your reconcile and post. The reconcile will pull the changes from the parent into the child. The post will push those changes from the child into the parent. So as long as you're doing that, you will see all the changes. The states in your geodatabase will not have an effect on who sees what data in that case.
So the users that, when they come in the next day and they look at that geodatabase, will they see all the changes?
Yes.
The zero change?
Yes. The question was, when the users come in the next day, will they see all the changes? And the answer is yes. Yeah. Oh, what IDE was I using? I was using Wing IDE. The three that I've seen the most common around our parts in Redlands are Wing, PyCharm, and PyScripter. Those seem to be the most commonly used. So the question was, would I recommend a GP service for this script? Not really. I don't. I'm trying to think of what. Yeah.
We already have a GP service,
Mm-hmm.
but it takes like 10 to 12 minutes just to reconcile a query. So,
All right.
is that a GP service issue or a database issue?
It's probably a database issue. The GP service is just going to. The question was, it takes a long. You have a GP service set up and it takes a long time. The GP, the service aspect shouldn't be playing any part in the length of time that it takes to reconcile. I would suggest trying to perform the same reconcile outside of the service and see if it takes the same amount of time.
And
Right.
second question is this script available online on this website?
Pardon me?
Is this script available?
Yeah. So if you go to this URL, the slides as well as all of the scripts that I demoed today are available at that URL.
Thank you.
All right, I'll take any more questions up here at the front. Thank you guys very much. It's getting pretty late. Thank you for attending.